of activity make you feel happy? You might enjoy an afternoon playing football or simply eating delicious chocolate cake. But why do these things make us happy? The reason is because of neurotransmitter called dopamine that our brain uses to let us know something feels good. Dopamine and other molecules in our body such as histamine, norepinephrine and epinephrine all are examples of amines. Two biologically active compounds, namely adrenaline and epinephrine, both contains secondary amino group and are used to increase blood pressure. Novocaine, a synthetic amino compound, is used as an anesthetic in dentistry. In this video, we will discuss such chemical reaction shown by amines. In alkylation of amines, amine can react as a nucleophile with alkyl halide via substitution reaction. Here, ALs are often poor, as the product of amines are still nucleophile and can react with more halide. This result is often a mixture of amines in various states of alkylation. Amines also undergoes acylation. Here, aliphatic and aromatic primary and secondary amines react with acid chlorides, anhydrides and esters by nucleophilic substitution reaction. The reaction is carried out in the presence of a base stronger than that of amines, like pyridine, and the product obtained is amide. Amines also reacts with benzoyl chloride, that is C6H5COCl. This reaction is known as benzoylation. Aliphatic and aromatic primary amines also undergoes carbylamine reaction on heating with chloroform and ethanolic potassium hydroxide to form isocyanides and carbylamine, which are foul-smelling compounds. Secondary and tertiary amines do not show this kind of reaction. This reaction is also known as isocyanide test and it is used as a test for primary amines. If we look at the reaction of amines with nitrous acid, we will observe that different classes of amines react in a different way. For example, primary aliphatic amine react with nitrous acid to form aliphatic diazonium salt, which being unstable liberate nitrogen gas quantitatively and alcohol. Whereas aromatic amines react with nitrous acid at low temperature around 273 to 278 Kelvin to form diazonium salts. Amines also react with aryl sulfonyl chloride, for example, benzene sulfonyl chloride, which is also known as Hinsberg reagent. It reacts with primary and secondary amine to form sulfonamides. Here, sulfonamides is soluble in alkali because the hydrogen attached to nitrogen in sulfonamide is strongly acidic due to presence of strong electron withdrawing sulfonyl group. Benzene sulfonyl chloride also reacts with secondary amine to form NN-diethyl benzene sulfonamide. Since NN-diethyl benzene sulfonamide does not contain any hydrogen atom attached to nitrogen atom, it is not acidic. Hence, it is insoluble in alkali. Tertiary amines do not react with benzene sulfonochloride. This property of amines reacting with benzene sulfonyl chloride in different manner is used for the distinction of primary, secondary and tertiary amine, and also for the separation of a mixture for amines. We have already discussed that aniline is a resonance hybrid of 5 structures. But where do we find the maximum electron density in this structure? Yes, the ortho and the para position to the amino group becomes the center of high electron density. Hence, amino groups are ortho and para directing and a powerful activating group. Therefore, it undergoes electrophilic substitution reaction. Let's discuss this in detail. Aniline undergoes bromination in presence of bromine water at room temperature to give white precipitate of 2,4,6-tribromoaniline. The main problem that arises during the electrophilic substitution reaction of aromatic amines is that of their very high reactivity. Substitution tends to occur at ortho and para position. If we have to prepare monosubstituted aniline derivative, how can the activating effect of NH2 group can be controlled? Well, this can be done by protecting the NH2 group by acetylation with acetic anhydride, then carrying out the desired substitution followed by hydrolysis of the substituted amide to the substituted amine. The lone pair of electron or nitrogen of acetanilide interact with oxygen atom due to resonance as shown here. Hence, the lone pair of electron or nitrogen is less available for donation to benzene ring by resonance. Therefore, activating effect of acetanilide group is less than that of amino group. Next, let's discuss how nitration takes place in aryl amines. Direct nitration of aniline yield oxidation product in addition to nitro derivatives. Moreover, in the strongly acidic medium, aniline is protonated to form anilium ion, which is meta-directing. That is why beside the ortho and para derivative, a significant amount of meta-derivative is also formed. However, by protecting the NH2 group by acetylation reaction with acetic anhydride, the nitration reaction can be controlled and the para-nitro derivative can be obtained as the major product. Whereas in sulfonation, aniline reacts with concentrated sulfuric acid to form anilium hydrogen sulfate, which on heating with sulfuric acid at 453 to 473 Kelvin produces para-aminobenzene sulfonic acid, commonly known as sulfonolic acid, as the major product. Do you know, primary aromatic amines forms arene disonium salt, which are stable for a short period in solution at low temperature. And the stability of arene disonium ion is explained on the basis of resonance. To understand this, stay tuned for the next video. Now, let's summarize what we have learned.
Manorama Horizon. Learning made simple.